CS Data X Lecture 14, Introduction to C Programming.
So first question you ask is why are we doing C? And the reason is because this is a special request by the engineering faculty because most of you who are going to be doing engineering would have to take like CS 1010 or CS 1010E. These ones will be taught in C. And C is currently used for low-level programming of devices and things like that. So it is useful for engineers who are in electrical engineering or computer engineering to know some C because you will need to work with it. But my personal opinion is that C is just like any other language. And what we've taught you so far in Python for CS1010FC is good enough, right? So if you have mastered the things that you're meant to have mastered, then it's just about learning the syntax and learning some special things about new languages. Okay, so C has some overheads that we will cover. All right, so it turns out that one interesting fact is that Python is actually written in C. In fact, C is important in the sense that many things today, kernels are written in C. C is not a bad language. It's a low-level language. It's very close to the machine. And it was earlier, so many of the later things are written in C. And once people write stuff in C, it's very hard to rewrite everything. So C is still a major player overall in many things. Okay, so these are the topics that we will be covering today. And essentially, the basic thing that I will try to do is not to teach you like new things, but I would like to try to relate what you've already learned in Python to C, right? So hopefully, instead of thinking of learning something new, you think of this whole process as thinking about what you already know and asking yourselves what is different or how is the same thing done in C. Okay? So first of all, the major difference between C and Python and also Java and Python is this thing about typing, right? So C is a very strongly typed language like Java, right? And the thing here is that variables need to be declared before they're used, okay? And the type does not change during runtime. It means you cannot go and change the type of variable after you have declared it. All right, so the general idea here is that once you declare a variable, you are actually allocating memory to store the variable. So for example, in this example here, you see float disk, right? So this disk is a variable name and float is the type, it's a variable type. Later we talk about different types. And after you declare that disk is a float, you can then start using it. You can assign this to 3.3. Now, float is just floating point, so it's decimal, right? And okay, if you look at all this double slash, this is for comments. So you double slash, you can just type your comments after that. Right, this is similar to your hash for your Python. All right, so another thing is you look at the code, it looks similar, but not the same. So this is the exponentiation in Python, right? This is Python. And this is the exact same code in C. So you notice that in declaring a function, so here you declare expt as a function, here you also, but in C you need to declare the return type. So that means that in C you have to tell, you have to declare right at the beginning what kind of a return value you will get, right? So what you're saying is that the numbers returned here will be floats, okay? And similarly, the inputs, you have to actually declare the data type of the inputs. So here x is a float and your n is integer. Okay, so if you compare these two, the code is similar, but this is the basic difference. Another thing is obviously you have this parentheses, this curly brackets. C is delimited using this curly brackets instead of using tabs. So here you can actually have different tabs in and out, whatever, it doesn't matter. So whereas Python is, you're forced to use the tabs, right, to actually go and scope your code and see the basic thing is this curly braces thing. Right. Then the other thing you notice is that the C statements end with a semicolon. It turns out that actually Python can use a semicolon as well, but typically we don't in Python, right? But C, you will see semicolons everywhere. Okay. So next, assignment operations. So you can declare and use the variables, okay, and identify the case sensitive, right? Just like Python. Okay, so you can do this. You can declare x as an integer and assign x to 5. Right, but there are also advanced operators. This is something I've seen before in Python, right? So it's actually something equals is equal to var equals var something p. Okay, so the different types of operators, okay, that you can go and check out by yourself. All right, so I'll give you as homework to check out what these operators are. So plus, minus, star, divide, right? Then the rest are different operators. C supports several different types of data types. So basically you have your integers, okay, which are whole numbers, both positive and negative. You have floating point numbers, which are decimal numbers, right? Float is for normal floating point, double is for double precision, so you can have higher precision, right? And this is what a decimal number looks like. So with integers, there's no loss of precision. With floating point numbers, you lose some precision, right? And characters and strings. So character is just one letter or something, or one symbol. A string is actually is a whole bunch of characters. So instead, it's actually an array of characters. We'll talk about arrays in a short while. So you use this single apostrophe to denote your characters, and for strings, use a double apostrophe. Okay, there are also other data types, pointers, structs, and arrays, which we'll talk about at the end. So basically here we're talking about the basic or primitive data types. Alright, so characters, they are individual characters which are digit or letter or symbol, right? And they're enclosed in a pair of single quotes, as I mentioned. So this is a character, okay, Z. This is the string Z. Okay, they're not the same. And essentially, if you try to do a car equals to 2 letters, this is going to give you an error, right? So it's legal. So let's take a look at some piece of code, right? So first of all, there are these include statements. Includes are basically for importing code, that's like in Python. So you have standard I/O is the library that does the printing and inputs. So I/O, input output, right? Then every single program must have this thing called main function. So essentially, what C does is that when you run a program, right, you go through all the functions and then look for this one that's called main function and run that. Right, obviously the main function can then call other functions. So how does this piece of code work? So what we're saying here is the following. You create a car array. So this is a string and it's private. Okay, and you have another string which is Cyclops sing. Okay, and what you can do here is that you have NRIC number which is 9300007, right? And then you'll have also a car which is NRIC check, which is Q. And what you can do is you can do a printf, okay, percentage %s, NRIC s, %d, %c, and reporting. What happens is that your rank, okay, would then be mapped to your %s. Okay, the name will be mapped to this one. NRIC number will be mapped to %d, and NRIC check will be mapped to %c. Okay, so essentially you have the following: private Cyclops saying NRIC s, this is reporting. Okay, I power. Okay, this /n is actually the return carriage return. Okay, so let's take a look. So this thing, as you saw earlier, is known as a formatting string. Okay, it outputs the string to the screen. New line here is not included, right? And the string will be formatted this way. And printf stands for print formatted. Okay, so as I mentioned earlier, you will map the different variables to the different output format specifiers. Okay, percentage something. Okay, and these are placeholders that will specify the type and format of the values. Okay, so now if you do %d, we're saying that it's an int. Okay, %f tells you that it's a floating point number. %s tells you the string, and %c tells you it's a simple one character thing. Okay, so for example, if you do %.2f, you're saying that you will actually output the float to 2 decimal places. All these kinds of specifiers are actually given in the specs. So if you're keen to learn more, you go check it out. Frankly, I also don't remember what they are. So for me, I will go and check it out when I need to use, right? Of course, if you write enough C code, you remember this. Okay, so in this class, frankly, it's not important for you to learn C very well, as in knowing all these things. The goal right now is for us to ensure that you have a sense of what exists out there. So in the future, if you need to write C code, you can go and check out. All right, then there's this /n and so forth. These are special characters, right? So /n is a new line character, carriage return. /t is a tab. Slash double quotes is double quote because you're using the double quotes to actually specify your string, right? So if you need a double quotes character inside a string, how? Well, you need to put a slash in front. Similarly, your percentage is kind of a specifier, right? So you need to basically kind of a sequence to specify percentage to display. Okay. Now, so let's talk about the declaration of C functions. So as I mentioned earlier, you must have return type, right? So for example, if you have float expt float x in n, Float here is the return type for the function expt. The main function returns int. Okay, so here would be the return type, right? And then the names of the functions are here. And then inside there, inside this parentheses, much like Python, you have your parameters. And then void tells you there's no input parameters. So, or you can just put nothing. Just put main. You just put main open parent, close parent, it's fine. Okay, so in this case, you have x as a float, right? And you have n as an int. Okay, so it's very simple. And then the body comes, right? The body is where you have the curly braces. Okay, so use void if it returns nothing. You can put void the parameter as well if you have no parameters, or you can put nothing. Okay, now you need to specify the return type of all functions and the types of all parameters if there are any. Actually, if your return value doesn't match the return type, right, then in fact the compiler can find this out and you will actually flag it. It's always compulsory to return a value. If a void type, you can just put a return, or you just basically end the whole function just like Python. Okay, and we can talk about how to return multiple values later on. Right, then there are this thing called sentinel values, which are actually the kind of solution to exception handling, because C does not have exception handling. So if weird things happen in your code, right, you need some way of informing the programmer that something weird has happened. So this is the basic problem, right? And the way to do this is to specify certain special sentinel values, which are kind of unusual values, so that you can actually see that something has gone wrong. For example, right, if you talk about a program that somehow computes widths, widths must be positive, right? So we can use, therefore, a negative width, right, to signal the error has happened. So essentially, you look at what the function is supposed to do. If there's some kind of value for which, you know, it's unexpected or weird, right, you can specify them as your sentinel values, which is why sometimes it's a bit not so convenient, because suppose your function, you know, it returns any value valid, then you have a problem, right? Because you don't actually have a means to do this, which is why exception handling is actually a much more elegant solution. All right, then you have booleans. Well, actually, you don't have booleans, right? So there's no primitive boolean type in C. So what we do in C is that typically the convention is to use 1 and 0 lah. So 1 would be yes, it's true. 0 would be false, right? And essentially, you just do it, you know, the way that you want to do it, and basically you can call it is boolean or something. Okay, so in this case, when you do x equals to 100 greater than 4, answer obviously is true. Right, so this returns you 1, and then when you print the x, you get 1.